Hello. In this session, I'm going to talk about quadrilaterals. Right, that's quadrilateral. Quadrilateral. That's a long word. What it means is simply a figure that has four sides. Like that. Four sides that are straight lines. Okay, my lines are not very straight, but you get the idea. So it can be at any shape and size as long as it has four sides. Now we know of some simple examples like squares and rectangles. So those are examples of quadrilaterals. Now, there is something special about a quadrilateral. No matter what the shape looks like, the angles inside, the four angles inside, they must always add up to give you 360 degrees. So we are talking about these angles. Those four angles. Okay, now there is actually a simple way to understand why. Now imagine drawing a line to join one corner to the opposite corner. If I draw this line, notice that I have divided the quadrilateral into two triangles, and we already know that the sum of angles in a triangle is 180 degrees. So if you have two triangles here, the sum of the angles in each triangle is 180. So 180 for those three, alright, on this side of the line, and 180 for those three on the other side of the line. So 180 plus 180 is 360. Alright, so what we have is sum of angles in the quadrilateral is 360 degrees. Now let's start with some familiar examples, like a square. We know that a square has all four sides equal, and it has all four angles equal, and each angle is equal to 90 degrees. So 4 times 90 degrees is 360 degrees. So in this case, we already know that the sum of angles of a square is 360. Now the next familiar figure is a rectangle. Right? So a rectangle has two longer sides and two shorter sides. Each pair is parallel, and all the angles are also 90 degrees. So therefore, the sum of the angles here is also 360 degrees. Now a slightly more complicated figure, which might also be familiar, looks like this. Like that. Now this is a figure where two opposite sides are parallel and the other two opposite sides are parallel. Now it looks like a tilted rectangle. If you imagine taking the rectangle and tilting it a little bit to one side, that's this figure. Now this figure has a name. It's called a parallelogram. So that's P-A-R-A-L-L-E-L-O-G-R-A-M. So parallelogram. Parallelogram. Right? Two opposite sides equal. So in this case, the sum is also 360 degrees. And we know it must be because we can always imagine cutting it up into two triangles. Right. Okay. Let's look at another figure. This one is like a parallelogram. It has all its sides equal. So it's like taking the square and tilting it a bit. That's what you get. So this is also a parallelogram, but it is a special type of parallelogram where all sides are equal. So it has a special name. It's called a rhombus. R-H-O-M-B-U-S. A rhombus. Now in both the parallelogram and the rhombus, the angles does not have to be 90 degrees. They could be, right? If a parallelogram has angles that are 90 degrees, that just means that it is a rectangle. So that also means that a rectangle is a type of parallelogram. That's how you can think about it. Now, there is something special about the angles in a parallelogram. The opposite angles are equal. You can easily tell because it is symmetrical. Alright, the shape looks symmetrical. If you rotate it 180 degrees, this angle fits into that angle. Right? So that angle is also equal to that angle. So the opposite angles are equal. And likewise, the rhombus also has opposite angles equal. Right, we have one more figure to look at. Now this is a figure which has two of its sides parallel, and the other two sides does not have to be parallel. Now such a trapezium, such a figure has a name. It is called a trapezium. T-R-A-P-E-Z-I-U-M. A trapezium. So that's that. So let me just look at a simple example. Suppose I have a quadrilateral that looks like this. I'm given that one angle is 90 degrees, one is 70 degrees, and one is 120 degrees. So the question is, what is x, the remaining angle? To do this question, we have just learned that the sum of the angles in a quadrilateral, a figure that has 4 sides, is equal to 360 degrees. So that means that if I add up all these 4 angles, the answer must be 360 degrees. Now since we know we are given 3 of them, we can get the remaining one if we subtract those 3 from 360 degrees. Now let me just start by adding those up. So 90 plus 70 plus 120 is 80 degrees. Right? So x is equal to 360 minus 280 is 80 degrees. So that's the answer. Now let's look at another example. Right, suppose we have this question. In which I have a figure like that and I'm given some of the angles. Alright, the outline of the figure is a 4-sided figure, so it's a quadrilateral. Now that angle is 60 degrees. This and this are right angles, and that is 20 degrees. And the question is, what is x? What is that angle? Alright, if I ignore this line for now, just look at the quadrilateral. Look at this shape here. Now I have these 2 angles, 90 degrees. I know that's 60 degrees. So that means I can find that angle. Because the sum of all 4 angles is 360 degrees. Right, now those 2 angles are 90 degrees. So that means those 2 angles add up to 180 degrees. So that means that those 2 angles must also add up to 180 degrees. So therefore, that angle would be 180 minus 60, which is 120 degrees. Or we can simply notice that because those 2 are right angles, therefore these 2 lines are parallel. And because they are parallel, those two angles are supplementary angles, meaning that the sum must be 180 degrees. So, and we get the same answer, that must be 120. Now that we have this angle, take a look at x. Now notice that x is next to this triangle there. So there's a triangle there, and when you extend this side, when you make this side, when you draw a straight line out from that side, it makes the angle x. So in other words, x is the exterior angle of this triangle. And those two angles are the interior angles that are opposite to x. Now remember, there is property of triangle that the sum of the interior opposite angles is equal to the exterior angle. Alright, the exterior angle is equal to the sum of the interior opposite angles. So therefore, x must be equal to the sum of those two angles. Let me write that down. X is equal to 20 plus 120, that's 140 degrees. So there we have the answer for x. Right, next we shall look at a polygon. Now, a polygon is just a name that we give to a figure that can have any number of sides. So actually, a triangle is a type of polygon. A square is a type of polygon. Right? Let me just draw that. That's a type of polygon. That's another type of a polygon. So that these have 3 sides and 4 sides. How about a figure with 5 sides? That has 5 sides and is called a pentagon. So that's a polygon. Can I have a figure with 6 sides? Right, that's called a hexagon. Let me write down the name. And so on. Okay, while we're here, I might as well write down the names of a few more. That's 7 sides and it's called a heptagon. Alright. There's 8 sides and it's called an octagon. Now I'm not going to try and draw the 9 and the 10 sides. I'm just going to write down the name. A polygon with 9 sides is called a nonagon, and one with 10 sides is called a decagon. Now we don't often see this, you're more likely to see maybe a hexagon or a pentagon, or maybe at most an octagon. Now we have learned that the sum, we are interested in angles here. We have learned that the sum of the angles in a triangle is 180 degrees. The sum of angles in a quadrilateral, a four-sided polygon, is 360 degrees. What about the sum of the angles in a pentagon, or the sum of angles in a hexagon, and so on? Is there a formula? So that's what we are going to find out. Now, what I'm going to do is to show you how we can discover the formula for the sum of the angles of a polygon. Now look at that. Look at this polygon. You are interested to know the total of those angles inside the figure. But for now, let's put that aside. Okay, let's look at something else. Something related. Now what I'm going to do is that I'm going to extend the line for each of the side. So for this side, I will make it longer. I will extend this. Okay, for that side, I will extend that. Extend that, and that. Right? Now look at, for example, that angle. That angle there is called an exterior angle. Now you remember that we have seen exterior angles before with triangles. Right, so that's an exterior angle. It's the same sort of angles. So these are exterior angles here, 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 and here. So these are all exterior angles. Now suppose that I want to find the sum of all these exterior angles. Maybe it's easier than finding the sum of the interior angles for a start. How might we do that? Okay, to see how to do it, I'm going to draw this figure again in a slightly different way. I'm going to make the pentagon a bit smaller. Okay, I have a smaller pentagon. Let me draw the exterior angles. Those are the sides produced, the extended lines. So these are the exterior angles. Here, 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 and here. So I'm interested in the sum of these angles. Now if you take a step back, you will see that these angles are basically the same as the angles that you would have if you have a point at the center instead of a polygon. What do I mean by that? Okay, let me draw it this way. Look at those lines. Those lines point in the same direction as these, but I have a point in the center instead of a tiny polygon. So it's as if the big polygon has become smaller and then has become so small that it looks like a point. But when the polygon shrinks, notice that the angles does not have to change. Alright, as long as I keep those lines in the same directions. Okay, all the extended lines there and there are pointing in the same direction. Therefore, the exterior angles, the angles here are the same. And if you look at that figure there, with the point in the center, we know the sum of those angles. They are angles, the total angles around a point. The total angles when you go one round around the point. That's 360 degrees. So with this simple idea, alright, that we can simply shrink the polygon until it becomes a point, we find the answer. We find that the answer to all these exterior angles is actually 360 degrees. So this is the sum of the exterior angles. Alright. Now notice that although I have drawn a pentagon, although I have drawn a 5-sided polygon here, this idea of shrinking the polygon is the same. It can be used even if I have a polygon with 6 sides or 7 sides or any number of sides. So we come to a very important result, and a very simple one, that no matter how many sides you have for the polygon, alright, for a polygon of any number of sides, the sum of the exterior angles is always equal to 360 degrees. So that's convenient. No matter how many sides you have, it's always 360 degrees. So we don't have to worry about whether it's a pentagon or a heptagon or a nonagon. It's always 360 degrees for the exterior angles. Alright, we must be careful here. It's not the interior angles. We're not talking about the angles inside the polygon. We're talking about the angles outside on the exterior. So we have this simple result. Now how does that help? How does that help us to find the sum of the interior angles? Okay, now suppose that now I'm just going to look at the simple example where all of the sides are equal, okay, and all of the angles are equal. So just as a simple example, now suppose I have a polygon where all the sides are equal and all the angles are equal, and suppose this is a polygon with say n sides. Right, now let me make that a bit more obvious first. Let me stick to this example for now. I have a polygon with 5 sides. Okay, now I'm going to look at the simple example, the simple case, where all the sides are equal and all the angles are equal. Now this type of a polygon is called a regular polygon. A regular polygon means that all sides are equal and all angles are equal. Okay, I'm going to look at such a polygon, and I'm going to look at this one that has 5 sides. Now that we know the sum of all the exterior angles is 360 degrees, so what is the angle, what is the value for one exterior angle? What is that? So one exterior angle would be 360 degrees divided by 5, because there are 5 of them. So that's the answer for one exterior angle. Now that we have the answer for one exterior angle, we can find the angle inside. We can find the interior angle. Okay, so the interior angle is this one, is the x there inside. That's the x. Now, the x is just next to the exterior angle on a straight line. So therefore, the x or the interior plus the exterior angle must be 180 degrees. So that means that I can find x if by subtracting the exterior angle from 180 degrees. Okay, there we are. Now we have the answer for one interior angle. So we are making good progress. Okay, you can calculate this quite easily by hand or with a calculator. Okay, therefore you can now find the sum of all the interior angles. Since this is a 5-sided polygon, there are 5 sides, all we need is to multiply this by multiply this by 5 because we know that it's a regular polygon, so all the sides are equal. Okay, so multiply this by 5. So it's just 5x. That's the total angle. It's 5x. So it's 5 times that. Right. 5 okay, 5 times of this. I'm just going to remove the brackets. Remember how to remove brackets? We must multiply the factor or the number outside the bracket by each term inside the bracket. Right? That's what we do when we remove the bracket. So we have 5 times 180 there. Okay, 5 times 180 minus 5 times that. Now when you multiply 5 by that, 5 will cancel with the 5 in the denominator, so that you're left with 360 degrees. So that's our formula. 5 times 180 minus 360. Now, I want you to take a look at this number 5. Now this number 5 came from the number of sides of this figure. So this has 5 sides, and we use this number 5 in calculating the exterior angle. Remember, we divided 360 by 5 because it has 5 sides. And later on, we multiply the interior angle by 5 down here because there are 5 interior angles. Okay, 5 sides, 5 interior angles. So that 5 is there because it's the number of sides. Alright, that 5 is the number of sides. So suppose now that instead of 5 sides, I have 6 sides. So imagine that you repeat all the steps, okay, to find the total interior angle. So what would you do different? What would you do differently? Almost everything is the same. Alright, almost all the steps are the same, except that instead of 5 sides, you have 6 sides now. So you must divide by 6 for the exterior angle, and you must multiply by 6 for the interior angle. So you would end up with a 6 there instead of a 5 there. Now, this understanding is very useful because it means that if I have a different number of sides, then all I need is to replace that number by the number of sides. It can be 4 or 6 or 10 or any number. Alright? And that means we have a formula now. Let me write that down. If I have a polygon with n sides, okay, the total interior angles so instead of 5, we have n sides there. Okay, bring this part away. So I was saying that this expression here, 5 times 180 minus 360, if you have a different number of sides, you can just replace the 5 by the number of sides. So if we have n sides, just replace the 5 by n. So let me copy this out, but change the 5 to n. So I have n times 180 minus 360 degrees. So then I have a formula now for the total interior angles for a polygon with n sides. Now, I have shown how to arrive at this formula by looking at regular polygons. Now, in fact, it can be shown that even if the polygon is not regular, that means that you might have polygons with different sides and different angles. So even if you have such a polygon, such an irregular polygon, the sum of the interior angles is still given by the same answer. So I'm not going to go into that. I'm just going to state this as a result that you can use for your questions. So remember that you have this formula for the total interior angles of a polygon of any shape, regular or not regular. Okay, so this is one result, and you could use this together with the result that the total of the exterior angles is 360 degrees. So again, that is true for a regular or irregular polygon of any shape. Let's look at a question. Now in this question, we are given a regular polygon. Now we are also given that the interior angle and interior angle is 140 degrees. So the question is, how many sides? How many sides does it have? Okay, so we can find this using the formula that I have written down just now. And let me just write this formula down again. Let's see. What I have just now was that for the total interior angles the formula is 180 degrees times n, the number of sides, minus 360 degrees. Alright, so that was the formula. Now let's try and use this here. Now what we are given is that the interior angle is 140 degrees and you have to find the number of sides. Now in this formula, the number of sides is given by the symbol n. So in this question, n is the unknown, it is the number of sides. So this is the n that we want to find. Alright. So if there are n sides, that means n can be 3, 4, 5 or any of these numbers, then there also must be n of those interior angles. If you have n sides, if you have 3 sides, you have 3 angles. If you have 10 sides, you have 10 angles. So if you have n sides, you have n angles. So in terms of n, right, the total, the sum of the interior angles is 140 times n. So according to this information, the total interior angles is 140 degrees multiplied by the number of angles. So therefore, both of these are the total interior angles, therefore they must be equal. This must be equal to that. So let me write down this equation. (180n minus 360n) from there is equal to 140n from there. Now notice that I've dropped the degree symbol for now. Okay, that's okay because it's the same degree, it's the same units for all the terms, so I can just put it back in later. So I have an equation. I can use algebra to solve this problem. So let me start by subtracting 140n from both sides so as to remove it from the right side. And I would add 360 to both sides to remove that. Right, let me add 360 first. If I add 360, alright, I have 180 n minus is equal to 140 n plus 360. Okay, now I subtract 140n from both sides. Okay, I need some space here. Let me clean that away. So if I subtract 140n from both sides, I have 180n minus 140n is 360. Now 140n minus 180n minus 140n is 40n. Alright, so therefore I can find n. If I divide both sides by 40, the 40 here cancel, left with n and On the right side I have 360 over 40. Okay, I can divide that. 0 and 0 cancel, and 360 divided by 4 is 9. N is 9. So the answer is that there are 9 sides. So nonagon. Okay, next I'll look at the areas of a parallelogram and of a trapezium. Now just to introduce the topic, let me start with the area of a rectangle. Alright, if I have a rectangle, all the corners are 90 degrees. Suppose that the length of this base is b, the length of this height is h. So we know that the area is the length times the width, or the base times the height. So area, I call it A. Area A is equal to base times height. Alright, now we look at a parallelogram. That's a parallelogram. Two sides are parallel and two of these sides are parallel. So what is the formula for the area of a parallelogram? Well, if the bottom here, the base here is b, right? The length of the base is b, and the height of this parallelogram is h, then the area is also equal to b times the height. Why? Why is that the case? In fact, it's quite simple to understand. Let's have a look. Now suppose that I cut this out into two triangles like that by drawing a line from one corner to the other. Now we know how to find the area of a triangle. Let me call this, call this A1 and call this A2. Okay. Now I can find A1, I can find triangle, this triangle. I can find its area. It is equal to the half of the base times the height. So A1 is half base times height. I can find A2 as well. Alright. If you look at this triangle, it's like this triangle upside down. Okay, this triangle is like an upside down triangle. So you can imagine that the top part is the base, and that this is the height, which is the same as h. So therefore, the area of A2 is also half base times height. And the total, we can get the total by adding A1 and A2, adding the areas of the triangles. Now if we add A1 and A2, we get the total area A. Now on the right side, if I add half BH and half BH, okay, this is algebra. It's like adding half an apple to half an apple. We get one whole apple. So half BH plus half BH is 1 BH, which is that formula there. So that means that for a parallelogram, you can use this formula. The formula is like the formula for the rectangle, but instead of taking the side as the height, we have to take the vertical distance from top to bottom as the height, because the parallelogram has a slanted side, right? And you can't take that as the height for the formula. It has to be the side that is perpendicular to the base. So that's the formula for a parallelogram. Now, finally, the formula for a trapezium. So a trapezium looks like this. It has two sides parallel, but the other two sides do not have to be parallel. That's a trapezium, and we want to find the area. Now, as it turns out, the formula is slightly more tricky. Now, these are the two parallel sides. I'm going to represent the length of one side by A, the length of the other side by B, and I'm going to represent the height by H. So the formula for the area goes like this. You have to first add the two parallel sides. So sum of the parallel sides. Now we have to do that first. So that means we should put a bracket around it to make sure that that is done. And then multiply this sum by the height. Okay? And take half of that. That is the formula. Now, how did that happen? Why does the formula look like this? Now, we can understand it quite easily using the same idea that we saw for the parallelogram. Draw a line from one corner to the opposite one. This divides the trapezium into two triangles. So let me call this A1 and call this A2. Okay. Now I'm going to write down the formula for A1 and A2 using the sides A, B, and the height H. So A1, right, is a triangle. Therefore, the area is half base times height. So half times A times H. A2 is a triangle. Now this time I can imagine that it's flipped upside down so that the top part is the base and this is the height is still H. Okay, so half times B times H. Now I can find the total area by adding up the areas of the two triangles. So adding up A1 and A2, I will get the total area A, and on the right side I would add them as well. So half AH plus half BH. Alright, so the way it works here is that I have written down those two equations. I added up the left side to give the total area. So if I add up the right side, it must also give, the answer must also be equal to the left side. So I have this formula for the area of the whole figure. Now if you look at this and compare with this, you see that they are the same because I have two terms here and each term has the common factor h. So I can take the h out and put a bracket around the remaining terms like that. In fact, I can take half and h out. Alright, half and h are both common factors. So I take out the half and the h, and I put the a plus the b in the bracket. Right, that's what we learned in algebra when we do factorization. So we got that, and this is exactly the same as this. So that's how we arrive at the formula for a trapezium. Now it is also often convenient to remember this formula in words. So in words, we would have the area of a trapezium is now let me write this as half, that half is half of, now I'll describe that as the sum of the parallel sides, okay, and then I have to times the height. Now, but it's better not to remember it as the height, because you can imagine that sometimes you get question in which this figure is rotated. Okay, it doesn't have to always lie flat. You might get a figure that is sideways or slanted. Okay, so then it wouldn't. You can't really just look at the height as in the vertical height. You must really look. You should really look at this as the distance between the two parallel sides. So, half of the sum of the parallel sides times the distance between them. The distance between half of sum of parallel sides times distance between them. Right, so that's a good way that I find for remembering the formula for a trapezium. Alright, we'll stop here for this session. See you next time.